Perfect. Thank
Thanks
you.
everybody for joining, and thanks to Chris for the presentation. My name is Bruno Zbinden. I'm a senior control systems engineer with Amazon Robotics R&D. I'm based out of Seattle. As Chris mentioned, I've been in the industry for a little over 20 years now, with the last 5 years working with Amazon Robotics. Today, I'll be talking about, I'll be giving everybody a little bit of a background history of Amazon Robotics as an organization within Amazon. We'll kind of talk about traditional automation and how some of those challenges in traditional automation become compounded with the e-commerce automation, which Amazon has started to ramp up in the last several years from its initial history with Amazon Robotics. And we look at two kind of specific examples within Amazon Robotics that I have worked on in the last several years. One of them is called an ASRS, an automated storage and retrieval system, and then the robotic stow project that I'm currently working on. Some of these acronyms will be defined a little bit later on and will make more sense. So with that being said, the background of Amazon Robotics, or what we call AR, before I get into Amazon Robotics, when Amazon started, as most of you guys know, I started selling books and CDs online back in the mid to late 90s. And so the traditional warehouse way of storing and retrieving product that has been sold online was implemented. And that's basically based on having aisles of shelves where you store your inventory. And then when somebody purchases a product from your inventory, then you have to go out and pick it. And those two processes are called pick and stow. So you pick an item from your inventory that has been sold, and you stow an item back into your inventory that you're hoping you'll sell later on. And that model works perfectly well, except if you want to start scaling up to very large volumes, as Amazon quickly had to do. So these are pretty old pictures of Amazon fulfillment centers, or FCs for short, where you can see, again, pretty dated pictures, but gives you a sense of having to have a really large warehouse with shelves containing your product, and then having people walk down those aisles. A couple of things to note here is that this model is not very scalable, especially for the growth rate that Amazon has seen in the last couple of decades, really. Pretty labor intensive to have people walk for miles in a work shift and have to reach on shelves. You can't really expand vertically very well, because unless you start adding ladders and start having to deal with safety concerns of having to climb up ladders, you're kind of limited to the height of a person being able to reach. And even then, there are some ergonomic considerations that have to be taken from repeatable motions of having to reach or squat down to pick items from up above or down below. So again, a lot of reasons why this model doesn't scale very well at a large volume. So Amazon Robotics started actually as a company that was not Amazon Robotics. It's called Kiva Systems, and it was a Massachusetts-based company that was founded in 2003, developed an alternative solution to this model where you have to walk around as a person to interact with your product. And they flipped that model to have instead the people stationary and have the product come to you in shelves. So how do they go about that? They implemented AGVs, and they were custom built AGVs by the company Kiva that would lift the shelf, or what we now call a pod, that contains the product, and bring it to a person that's either responsible for picking or storing that product on that shelf. And that's what that product looked like at the beginning. And even to this day, if you were to go into an Amazon fulfillment center, where there are different type of fulfillment centers, I should mention. We call these the sortable fulfillment centers, where basically you have relatively small items, nothing like refrigerators or TVs that require, larger shelving to be stored. Those are stored in different fulfillment centers. But Amazon sortable fulfillment centers hold products that can basically be handled by a person. And on the top right here, you see a Kiva robot, what we still call as a Kiva robot, um, that basically was custom designed by the Kiva company to be able to navigate through as an AGV with the payload being set on top. So I'll show a video here at the end of this slide on what this looks like in a fulfillment center ride. What this means also is now that you need to integrate and develop and integrate more intelligent software that will know where your product is in the inventory and on the shelf physically. And when an order is placed by somebody on the internet, that robot will know which shelf to go pick from your floor and where to bring it to a person to retrieve the item from the shelf. There's also the consideration of safety. So now we've made the process a bit more ergonomic, considerably more ergonomic for the human person. They don't have to walk as long or as far. The shelves are designed to be, again, a bit more reachable. The building can be designed to be more, around this model, more efficient. So you can have multiple floors with these shelves or AR floors, what we call soft pods that contain the products. And then you put a fence around the area that the AGVs, the Kiva robots, are moving. And in the perimeter of that fence, you have openings with safety precautions where the person, as shown in the picture here down below, either picks or stows the product on the shelf. As I mentioned before, the pod is brought over by the AGV to the location in the fence that allows the person to access the pod in order to pick or store the product. Kiva Systems was purchased by Amazon about 11 years ago, 2012. It was at that time, it was the largest purchase from Amazon of a company or acquisition. And immediately Amazon basically completed the contracts that Kiva had with other customers and made the technology proprietary to Amazon only. And now this is what has become Amazon Robotics. And I'll switch over to a video here to show you what this looks like nowadays. And I'll kind of jump around a little bit on these videos to give you a sense of what's going on. But you can see here the AR robots or Kiva robots have the functionality to navigate to fiducials on the floor. So there's a grid pattern on the floor. They can lift the pots and navigate in aisles that are made by the pots themselves. Let me jump over to a place in the video where you can see how the human interacts with the pots that have been brought to them. There's software that tells the operator what item.
The videos, you have to switch your monitor maybe.
Oh, is the video not showing over?
No.
Oh, okay. Yeah, sorry. Let me go back to the presentation then and maybe switch the screen. I'm going to stop sharing for a video for a second. Okay. So hopefully the video is showing now.
Yes, perfect.
Okay, so let me go back to the part where I started talking about showing the Kiva robots right about here. So here you can see the Kiva robots interacting with the shelves or pods, where they can navigate under the pods, lift them, and then carry them in by following fiducials on the Kiva floor, and bring the shelves over through aisles. There's this part of the video that'll come across over where the shelves are being brought over to operators on the perimeter of the Kiva floor, where they will interact with the pod by basically picking or storing. In this case, in this part of the video, this person is responsible for picking items from the pod. Okay. So I'm gonna switch over again to the other screen for the presentation. Okay. So now talking about ASRS, or automated storage and retrieval systems. These are fairly common on large warehouse, not just Amazon. For example, DigiKey, I know, uses a lot of ASRS, and they're mostly used for handling large products. As I mentioned before, TVs, refrigerators, PCs, things that you typically need a forklift to handle from the shelves. And these are just off the internet pictures of not necessarily Amazon fulfillment centers that show what an ASRS, traditional ASRS automated system may look like. Nothing too novel here. This technology has been around for a while. But in this model of automated warehouse inventory and storage and retrieval, the product remains on stationary shelves, and the automation system moves in between the aisle, within the aisles between the shelves to pick and store the product from the shelves. ASRS can be large and lack the ability to multiplex operations, therefore limiting their scalability. But the reason why I'm bringing them up is because at the end of, towards the last few slides, I will combine a couple of these technologies to show an example of the products that Amazon is currently using with Codesys. And it's worth mentioning in both of these examples, for both ASRS and the Kiva floor for sortable products, that the king metric that governs how efficient your automation system is called GCU, or gross cubic utilization. Basically, how much of your available space in a shelf are you using? So we talked about traditional automation, and now let's talk about some of the challenges associated with e-commerce automation. The vast majority of automation systems are based on a very simple principle: repeatability of the process. Whether you're making any type of widget, as simple as making cookies, to something very complex as airplanes. Developing the manufacturing process, can be simple and complex, but it's ultimately based on, you have to have a repeatable process. And typically in automation, we refer to that repeatable process as a recipe. So once you've engineered your automation system, you worked out the kinks, debugged it, you kind of lock that process down, and you call it a recipe. And for as long as all the variables are maintained, your process is repeatable, and you'll be able to continue making as many widgets as you need to. In our case, for Amazon, if we were still only handling books or CDs, our problem would be basically constrained within this domain. It would be fairly repeatable to build an automation system around a product that we more or less know what its shape, size, weight, and relative location is in space. However, one of the problems when I first came over to Amazon from the aerospace industry has been the inability, or the challenge, to pin down this repeatability process, just because of the almost infinite combination of items and their variables that Amazon offers on their platform. We're talking about millions of items that are packaged by the suppliers that supply those items to Amazon very differently, and that's very hard to maintain. So we have to basically come up with solutions that will comply to these highly variable environment. Control system needs tight integration with software and cloud-based services here at Amazon to determine what operation to execute next. The automation process can no longer be based on a recipe of predefined steps in the process. As I mentioned before, even if you're making an airplane, ultimately that recipe is locked in place and the airplane isn't going to change in the process of you making it. One of the another challenges with Amazon is that we want to deliver we have make a promise to our customers to deliver what they've purchased very quickly to them. And so we need to keep it in stock, and we need to be able to identify where it's at in stock around the world as close as possible to that person that's purchased it, and pick it within a day or less even now. So the control system needs to be very tightly integrated with cloud services in order to receive an order and act upon that request. So we need to have explicit and quick data transfer between both what we refer to as the software layer and the control layer. And the software layer obviously being the inventory management systems of a warehouse, not just a local warehouse, but warehouses across the US, warehouses across the world. Another challenge that Amazon faces that became very obvious, especially during the last few years of the COVID pandemic, is the dependency on a single ecosystem PLC architecture, which becomes a double-edged knife for both scalability and supply chain challenges. The later being the challenge that we faced in the last several years that a lot of industries are facing. So what I mean by a single ecosystem PLC architecture, when you have a PLC from a specific vendor, a servo drive, a motor, a servo cable, I/O, that all go in a cabinet. If you're using the same vendor or OEM for that PLC system, it is the advantage of that is that it's more or less easier to integrate. It's a plug and play system. You still need to have a lot of skill in doing that. I'm not minimizing the required skill set to do so, but your integration is going to be considerably faster and easier in general. The flip side of that double-edged knife is that now you're kind of locked into that one specific vendor. So if that vendor starts having problems with supply chain, or your ability or your need to scale your automation system exceeds the ability of that vendor to give you their product, that's a problem. Also, we have to think about our dependency on a single vendor as being a potential risk. If that vendor goes out of business, then all of our control architecture that we want to continue deploying to literally thousands of sites becomes dependent on that vendor. So then we come to why is Amazon starting to use Codesys? What are some of the advantages? As I mentioned before, trying to automate a process around non-repeatable variables, for example, the shape of the product and its relative location, to mention the most important ones, requires a higher level of control integration with sensors, actuators, and the software layer. Off-the-shelf automation vision systems are also based on limited number of variables in the process. I'm sure the majority of you guys have used off-the-shelf vision cameras that give you a set of tool sets in order to implement vision systems in your automation process. But here again, the processing of vision is based on that limited data set in order to make a decision. When coupled with large data sets, machine learning and artificial intelligence provide a very powerful set of tools that allow you to achieve, or allows us to achieve, a higher level of flexibility in the automation process that we're looking for. Here again, traditional PLCs do not provide these tools, and direct and fast integration between software and control is rather difficult and often relies on proprietary communication protocols. Codesys addresses the following immediate tasks. As Chris mentioned earlier in today's seminar, it's hardware agnostic, so that's of high interest for Amazon. The variability of target platforms that it can be deployed in, again, goes back to the hardware agnosticism, but also platform agnosticism or variability, not necessarily agnosticism, but variability in communication protocols and drive manufacturers. The ability to combine both higher level programming languages with the control layer is of high interest for Amazon applications. And again, the reduced dependency on single source suppliers. Implementation of automated build and deployment pipelines for PLC programs in the same way that software applications are automatically deployed. What I mean by this is, again, because of the size of the scalability of our automation systems, it's rather non-scalable to say that when we want to update a PLC or an automation program within our network, and our network constitutes of thousands of installations, that we need to do so by having a controls engineer or a maintenance person local at the website or the fulfillment center update the program basically with a laptop connected to the PLC. What we strive to do, and we've been able to implement with Codesys, is our ability to automatically build and update PLC programs through the cloud. Okay, so now for the fun part, give you a little bit of history of Amazon Robotics, an introduction to two traditional automation systems, one which was kind of flipped around by Kiva Systems, and how we are able to now utilize that model and continue to automate on that model, and then also the ASRS system. So now I'll switch over again to two videos, online videos that demonstrate these projects. So hopefully I don't get stuck on commercials here from YouTube. But this is a project from a couple of years ago. This is an alpha implementation of and I'll pause the video for a second, of a automated storage and retrieval system. We talked about an ASRS, but this is how Amazon has continued to evolve the implementation of an ASRS for sortable products, where again, we're combining the flipped model of having the shelves that contain the products be brought over to now an automated system that's picking and storing the items from those shelves. This is a containerized storage and retrieval system. Containerized in this sense means that the product's actually in a container, that we refer to as a tote. And you can see a FANUC robotic arm here with a custom designed end of arm tool that is basically performing both actions in the same operation. It is storing an item and it's retrieving an item. And what I mean by an item is we have multiple items stored in these containers or totes. So when an order is placed on the internet, that order will make its way to a fulfillment center where a robot will bring a shelf to another robot that will pick that tote from the shelf, and then put it on a third robot that will then bring it to a human to basically pick that item. It's considerably safer because now humans are in no interaction with any of the shelves, and we've completely improved the ergonomic interaction between humans and the process of picking an item, which will be shown here later in the video. I'll fast forward to it right here towards the end, where now the operator is basically in what we call the power zone, where the item is basically at waist height, and they don't have to overreach or underreach to pick that item. And then finally, the project that I'm currently working on. So obviously it goes without saying that this automation system that I've shown was one of the first alpha projects that we worked on implementing Codesys. On the project that I'm currently working on, I can only share the publicly available details of this project, and I put the links on the presentation if you guys wanted to read this article, if that presentation is made available to everybody that has attended the conference. But here again, what we are doing is on the previous video, I mentioned that we are automating the process of picking and storing containerized items, but now we're trying to automate the process of interacting with our current set of pods or fabric pods, which is a more challenging process because now we have to directly put an automation system that'll interact with the individual items and not the containers that those items are stored in. So this is a simulation of having basically a automation system pick items and store them or pick them from the shelves. And I'll jump ahead to a video that shows one of the examples of how the control layer needs to be interacted tightly with software layer for the purpose of machine learning. So in this video here that I'll show, this is what a perception system, how it's able to identify open space within a shelf, which a PLC cannot do. But then the soft PLC in this case will receive commands from software to store the item in a fabric pod. And again, how to execute what a human is able to execute very easily, which is to actually make room in a shelf where room may not have existed before. And with that, that is the end of my presentation. Thank you so much for everybody for sitting through it.